In this section, I'm going to look at the most practical use of coroutines in Python, which is to use them to write things like network services. To introduce this section, I'm going to first write a little Echo Server program using sockets. So I'm going to make a program called echoserve.py, and I'm going to use Python's socket module to do some low-level network programming. If you haven't used sockets before, I apologize in advance. This will be your crash course in network programming. What I'm going to do is make a little Echo Server function. And the way that this is going to work is I'm going to create a network socket. I'm going to bind that socket to a port, listen for connections, and then go into a loop where I wait for connections to show up. So what's happening here is I've opened up a network port, waiting for connections, waiting for something to show up. I'll print out a message sort of saying where the connection came from. And then I'm going to go ahead and handle the connection. The way that the connection is going to be handled is there's a separate function that does this. And what it's going to do is it's going to read from that connection. So it'll get some data. Okay, we're reading sort of a block of data. If there is no data showing up, then we're done. And then what I'm going to do is echo it back. Maybe I'll put a prefix on it just so you can see it. So I'm going to echo back what we got. Okay, so this is a prototypical example of writing like a little network server in Python. Keep in mind, this is just using normal Python functions. There's nothing tricky about it other than the fact that it's using sockets, I suppose. So here's how something like that might work. Got an Echo Server. I'm going to go ahead and run it down here. Okay, so we're going to run this Echo Server program. That's running there. The way that somebody would use this is they're going to connect from a different terminal. This is going to test my terminal handling abilities here. But what I'm going to do is open up another window where maybe I establish a connection to my machine. I'm going to say, okay, connect to localhost 25,000. Down in the bottom, you see it telling me that it got a connection. And then if I type things into it, you should see it echoing things back. Okay, so it works. We're good. Now, one of the problems with this code that I wrote is that it is not able to handle more than one connection at a time. For example, if I were to open up yet another terminal window here and try to connect to that server, you'll find that it is completely not responsive to me. The reason it's not responsive is that it is solely focused on the one connection that it does have. Essentially what happened in that code is it got a connection. It kind of went over to Echo Handler. It's handling the one connection right now. This second connection is not going to work until the first one closes. So for instance, if I kill the first connection, then the other client becomes alive. Essentially, we're dealing with a concurrency problem here. We need to handle more than one client, but we don't quite know how to do that yet. So one of the solutions to this problem, to handle multiple clients, and this is kind of a classic solution, is to use something like thread programming. Python has a module called threading that you can use. And the idea on that is that you would create a thread where you launch like that echo handler and then make it run concurrently. So you might modify the code to create like a thread object or something like that. If you make that change and run the code, what you will find is that you can now have multiple connections. Like there's one connection. Here's another connection. Got two things connected at the same time. They're essentially running in separate threads using the threading module. Now, doing something like that works fine. You know, if you have a small number of like connected clients, one of the downsides of threads is that it starts to get sort of very unwieldy if you have a large number of clients. Like if you started to have like thousands upon thousands of connections sort of being set up, it can be very difficult to manage that. It can be very resource intensive. And it turns out that this is one place where coroutines are being used in Python. And to illustrate that, what I'm going to do is I'm going to modify this code to use coroutines. I'm going to take this Echo Server code and I'm going to write it to something called, I guess, a Echo Server. I'm going to make a different file. This is going to be the asynchronous Echo Server. Instead of using the threading module, I'm going to use Python's async IO module. We're going to use some features out of that. And the very first thing that I'm going to do is I'm going to go through and I'm going to change all of these functions into async functions. These are coroutines. I'm going to change the code into coroutines. Turns out that if you're working with this async IO, you also need to interact with an event loop. We'll talk about how that enters the picture in a second. So there's going to be an event loop. I need to set the socket into something known as non-blocking mode. And then what I'm going to do is on these socket operations, I'm going to start doing an await operation. Okay, so the code is going to change very slightly. What I'm doing here is waiting for a connection. Instead of launching a thread, I'm going to create a task down here. So I'm going to say make a task where we have the echo handler with the client there. Okay, so we're going to change the thread thing to do that. Down in this echo handler, there's going to be an extra loop argument. And again, I'm going to change all of the functions to use await. Okay, so it's going to be some minor changes to the code. We're using this kind of await keyword here. I think that's good down there. And then in order to run the code, what you have to do is ask asyncio for an event loop. And then I'm going to do this run until complete stage where I say, okay, run this echo server on that port. So what I've done is I've changed this code to use these magic sort of async functions, and I'm using the await statement. The code actually looks very similar to what we had before. And so let's go ahead and kill these connections. And I'm going to try to run this new version of code. Okay, so echo serve. I've not done it right. I have to pass in the loop as an argument, partly because these operations need the loop there. Let's go ahead and try that one more time. Okay, so I've got that running. If I've done this right, I should be able to connect. Okay, it's responding there. And I should be able to do it from multiple clients. Essentially what we've got is we have the ability to do like concurrency, like concurrent clients using these coroutine functions. One of the things that's kind of amazing about this is that this new code does not involve anything like thread programming. There's actually no threads at work here. There's no separate processes or anything like that. It's entirely built up using coroutine functions. It can actually handle thousands upon thousands of clients. It's actually much more resource efficient than using something like threads. The other thing that's kind of amazing about it is that the code almost looks exactly the same as what somebody would write using thread programming. Just to see that, here's what the thread programming version looked like over on the right. The code on the right is the one that we started with. And the code on the left is the one that uses coroutines. There's a few little minor differences, but the overall kind of flow of the code looks almost exactly the same. And that's actually one of the big appeals of this coroutine feature in Python, is that you can write code that looks very kind of normal looking, yet can handle things like lots of concurrency and other things in like network services. So this is where it's being used the most. In the next part, I'm going to say a little bit about how this actually works under the covers, or what is actually happening here.